Okay, so this class is ACR 170. This class will be taught as a hybrid, which means a lot of the stuff that we do will be online, just like we've done in the past. Um, I hesitate to put it completely online because I do think you would benefit from a little bit of face to face. But this class is not a lab, so we're not going to be building ductwork or anything like that. This class is heat load and duct design. So we'll get into that into more of the topical stuff. But for now, I just want to give you a little bit of a layout of how this class is going to go. So the class is scheduled to meet on Tuesdays this semester, and due to due to social distancing stuff, we still do have limits on how many people we can have in the classroom at a time. So I'm probably going to have to split that up. But because the class is short, you're only talking like an hour at a time instead of the 5 hours for the lab part. I'm probably going to schedule like A group and B group on that Tuesday since the class is scheduled just for Tuesdays, and then just do like one early and one mid morning. So that way it kind of gives everybody a little more chance to come in, and we'll just have to split that kind of amongst whoever's coming. Now, I am going to put most of the material online, so the stuff that we talk about in class will mainly just be supplemental to the online course. I don't have the online course built yet, so be patient. I haven't ever taught this class online before, so I'm going to be building as we go. And then the stuff that we do in class, we may be building off of what the modules are talking about, and I may be showing you some other techniques that I've used in the field or that I've seen. So maybe a little more practical usage of this stuff. And we may not meet the full 8 weeks, even if we feel like we've covered it in a 4 or 5 weeks or something. So we'll just kind of take that as it comes. So this class is heat load and duct design. So the term heat load means you're calculating the amount of heat that's coming into a space in the summertime, and you could do a heat loss load as well in the wintertime, to where you're calculating how much you're losing in the winter. So in the summer, hot goes the cold, heat's coming in, and so you have to calculate how much heat that building is potentially taking in so that you can size your equipment to remove it. That's the whole purpose of an air conditioner. So we size in this area, especially we size our equipment for cooling load because we can always add auxiliary heat. We can add backup heat. So that's something that we're going to get into that later, but just kind of let you know what these terms mean and what we're going to be doing. So first of all, we're going to be establishing a heat load, calculating it based on individual structures, the components that make up that place, where it's located, how much sun it gets, the way it's facing, all that stuff calculates in. So this is trying to get you the best sizing for your air conditioning system so that you can match that load and remove the right amount of heat without being oversized. So that's the purpose of doing a heat load. And now for any new installation that has to go through inspection, every new installation has to be inspected, has to pass inspection. You do have to have a heat load for that. So some of your parts houses will do this for you. Some of your sales reps and stuff, have some software available. Some of them may charge extra for that. Some of them may do it as a service. But either way, it's a good thing to know how to do. And you may be doing it yourself, or you may work for a company that wants to do it, or has tried to do it, or needs to do it, and they don't have someone on staff that can. So that's where you may come in, and you may become that resident heat load, calculation specialist. So if this is something that you enjoy, that comes easy to you, you may do it a lot. You may go to work for even a distributor that sells equipment, and part of their services are providing heat load calculations to their contractors, and so you may be able to do that. So if nothing else, it helps you see sizing and what all goes actually into that. And even on the service side, sometimes the sizing comes in because the duct sizing or the system sizing. If a system is undersized or oversized, you could do a quick heat load on it and figure out, oh, this is why they're having this problem. This is why they're not removing humidity properly, or this is why the system just can't keep up because it's too small or whatever. So same way with duct work. So in the duct design portion, we get into the sizing of duct work, the design of duct work, the different fittings and different types of configurations that you may run into, how to properly size and configure your ductwork to where it produces the right amount of air with the least amount of disturbance to the home. So you don't want it to be so loud that you can't hear the TV when the unit kicks on. So that's something that we try to avoid or eliminate or improve upon. So sometimes if it's an existing system, you may do a duct inspection and determine that the system is completely undersized or the duct is undersized, and you may have to request that they make some changes to that to match the new system or to improve the problem that they're having or whatever. Sometimes it may be that one room isn't getting conditioned like the others, and sometimes that comes into play. So you've got one room that just stays cold all the time, even when everything else is comfortable. And so what can you do to meet your customers' needs? So that's the idea behind this, that it's heat load, it's duct design, it's matching the size of the equipment to the conditions, and it's also matching the ductwork to the right amount of airflow to each room or each space, and to the overall block design or the overall home or building. So that's kind of where we're going to go with this. But just kind of give you a little bit of a heads up. Not going to spend a ton of time on this, but the majority of the class will be online. At least the way I'm planning to do it. And then what I would propose is that when we come in for class, if you bring your laptop or whatever, if it's something that you're working on a computer, I can help you all. I can help work through some of this stuff, help answer any questions that you may have. And then I'll probably do some demonstrations and stuff at times, but I'm not going to spend a ton of time going over this because I'm going to be doing these lectures on here, and I'll be posting video lectures from other people that are doing this that are going to help you work through, softwares or spreadsheets or do manual calculations by hand. There's different methods to use this. Apps, there's a lot of stuff out now that's really easy to do. So even being able to decipher those and say, is this one a good one? Is this one, kind of, not meeting all the needs, or is this sufficient? So don't overcomplicate it, but at the same time, do realize that it is a pretty complicated procedure, or it can be. So in a basic 1,500 square foot house that's a ranch house that you've done a million times, those aren't too bad. Usually they'll follow some basic rules of thumb and you can get by pretty well. But when you get into the home that has a glass front on it, completely exposed glass, and ceilings that are 20 feet tall, what do you do about that? How do you calculate that? So that's where some of this may come in, to where you have to really match the load, because if you have extra windows, extra tall ceilings, some crazy building materials, and you don't match that, you just use a rule of thumb, your system's not going to perform like it should. Your customer's not going to be happy, and your system probably isn't going to last as long as it should either. So that's something that we want to eliminate. We want to make the system as efficient as possible and remove the right amount of heat, the right amount of moisture, and provide the right amount of heat. So that's where we're going to go with this. So I will be sending out some details on times. I'm inclined to split it by Group A and Group B, just like we've done in the past. I know there could be some time conflicts that arise because this is just on a Tuesday. It's not Tuesday and Thursday. If there is an issue that you just cannot come, do the online stuff. Like I said, the stuff in class is supplemental. So I'm not going to be taking a grade for those days. There may be some, I'm not going to say you won't be doing something in class sometimes, but I'm not going to be taking those up for a grade. The stuff that you're required to do will be online. And then when you come into class, we'll just be, just sort of tying up those loose ends and maybe helping you work through this stuff, because you're going to have a couple of projects that you're going to be doing. So this may be more of an ongoing thing instead of just being a few random quizzes. You're going to be asked to do a heat load. You're going to be asked to do a duct design. And so hopefully when we come into class, you're going to be able to bring in any questions you may have, let me demonstrate and help you through it. And then, hopefully this will be one that you're bringing in your laptop, and, you can just sit at your table and start working on your stuff, and I can just sort of help you work through it. So that's the way I see this working. Haven't ever taught it in this format before. Usually I've just done it in person, but given the nature of everything, we may do it that way. We may actually meet in a computer lab and just work on the computers in the lab. that may be an option because we usually haven't been able to have access to those. But since we don't have a lot of people on campus right now, we may request a lab and we may meet in there. So that's actually a pretty good. I may actually do that. It may be a better possibility. So like I said, it's still fluid at this point. I'm still trying to figure out the best way to navigate this, but I will let you know how we're going to split this up in the near future. So I'll be sending out a notification on Blackboard. I'll probably send something on Remind as well so that you know how it's split up. If you have some sort of issue with meeting at those times, let me know. If you cannot come because now you have a work schedule on Tuesdays because you've been meeting on Thursdays, then try to do the online stuff. You'll be fine. I'm not going to be too super strict on this as long as you're upholding your end of the deal and you're doing your assignments. And if you need some additional help, I don't care a bit to help you. Come if you have me on a Wednesday or something, bring it with you. I can help you out. So that's kind of where we're going to be. I will be reaching out to you soon.